Okay, so for this problem, you remember when we were talking about if you have a circuit that where all the resistors are in series, then the current is the same going all the way through. So like, I'll just draw it really quickly. So if we had something that was like this, then the current I would be the same going all the way through. Okay, and if we had something that was in parallel, do it in a different color. Say it was like this, going all the way through. Then in this one, the voltage is the same throughout the circuit. So whatever the voltage is here, it's the same here because this is all as if it's just one point. So in series, so this is parallel, and this one is in series. So in the series one, I is the same. In the parallel one, voltage is the same. And in the series one, you just add the resistors together. And in this one, you do that 1 over R1 thing. Okay, so we're looking at this one. We have both some series things, and we have some parallel things like these guys here and these guys here. And the thing to keep in mind is that this whole parallel bit in here, this parallel bit is in series with R1 and R6. Okay? So, the first thing you do when you have something like this is you try to identify what you're not given and what you need to be able to find what you're not given. So you know the voltage is 60 volts from here to here. You know what R1, R2, R3, R4, R5, and R6 is. Okay. What we don't know anywhere is I. We don't know what I is anywhere. So, I mean, the way I would start this off is by trying to solve I. So the way you solve I is what is it? Here, let's draw our little triangle over here, V, I, R. We drew this one last time. If you want to find V, you just cover up V and you're left with I times R. If you want to find R, you cover up R and it's V over I. Okay. So in this case, we want to find V. Sorry, that's not what I'm saying. We want to find I. So I equals V over R. Okay. So I'm just going to write that up here. I, and I want to find IT right now. Okay. So IT equals VT over RT. Okay, so I noticed we have V, I noticed we have all of the R's, I noticed we don't have any I's, so I'm going to try to solve for IT. Okay, so then we figure out what does VT equal. Well, VT equals this, 60 volts right here. So VT is 60 volts. Okay, and RT is what we want to find out. Okay, so these two resistors, R4 and R5, are in series with each other. So we can simply add those two, and this branch would be 70 kilo ohms. Okay, and this R2 and R3 are in series, so we can add those two, and that's 50 kilo ohms. Okay, so this branch here is in parallel with this branch here. So we had that water example. So we have our big bucket of water and a little spout here, and the water is coming out of the spout. And below that we have two paths the water can take, I guess. And some of the water goes down this way, some of the water goes down this way. The amount of water that enters will be the same as the amount of water that's sort of collected at the end. Okay. So, but it splits off here and it splits off here based on how, I guess, wide these paths are, how jagged they are, how much resistance they cause the water to encounter. So this branch encounters a 50 kilo ohm, let's just say, resistance, and this branch a 70 kilo ohm resistance. So to figure out what the equivalent resistance is for this branch here, we'll call this R, I don't know, E for equivalent, okay? Oh, actually, let me see. 1 over R equivalent, okay, equals 1 over 50, the first branch, plus 1 over 70, okay? So then you go, what does that equal? You can go through, find the common denominator, etc. You can also plug it into your calculator. 1 over 50 plus 1 over 70 equals, and then there'll be a little x to the negative 1 sign on your calculator. You can press that. When you put anything to the negative 1, that's like doing the inverse of it. Okay, so that's actually what you want to do to the final answer to get the inverse of it from this part. Okay, hopefully that made sense. So you're going to do 1 over 50 plus 1 over 70 into your calculator. Okay, so if you put that in, I'm just going to do it right now. 1 over 50 plus 1 over 70. Give me 1 second. 1 divided by 50 plus 1 divided by 70 equals something like 0.034. Okay, so if I just put it straight into my calculator, it gives it to me as a fraction, which is 0.034, and the numbers sort of keep going. Okay, and then what I'm going to do is I'm going to take the inverse of that, which is the same as like 1 over that, in order to flip this one around. So then that equals, taking the inverse, 29.1. No, 29.2. 22 kilo ohms. Okay. So that's 29.2 kilo ohms is what this whole bit in here is equivalent to. Okay. So we could have these parallel things in there, or we could just replace that whole bit with one resistor that was 29.2 kilo ohms. Okay. So pretend this whole, everything inside this little circle here is 29.2, which means we have now R1, which is 10 kilo ohms, RE, which we were calling to be 29.2 kilo ohms, and R6, which is 50 kilo ohms. Okay. Now we can simply add those three numbers together to get our RT, and that's because that would mean we've calculated every single resistor that's in this circuit. So we do R1, which is 10, plus 29.2. And you may want to include units depending on what your teacher is looking for. That's a 9 right there. It's a really big 9 now. 29.2 plus 50 equals what? Who's quick at math? Plus 89.2. Obviously, funny how sometimes it's tough to do simple calculations in your head. 89.2 kilo ohms. Okay, and what does that equal? That is our R total. We've now calculated every single resistor that's in this circuit. Okay, so what sort of happens in this circuit is we have water. Here, if I was to sort of draw this again using our water example, we have water falls out of this spout and it goes through this. Let's do the pipes in a different color. It goes through this pipe here. Okay, and then once it goes through that pipe, it splits off into two other pipes. Okay, here, and each one of these two pipes has sort of like two spots in it. So it's the other spot, and then they all come together, sort of dump into one thing there, and then they go through the last pipe. There. So the water's path is it's leaving here. The water, or the current leaves here. Okay, so that's like the water leaving here, and it goes through. All the water goes through this first resistor. All the water leaving that will go through this one. Then some of the current goes up this way, and some of the current goes this way. Okay, so now the current is split. How does it split? It splits based on the resistance that it faces. So if one path is really hard to go through and the other path is really easy to go through, it'll want to go mostly through the easy one. And this one, they're pretty similar. They're a little bit different, but they're pretty similar. So that's like the water splitting a bit more towards the 50 kilo ohms and a bit less towards the 75 kilo ohms. Okay, and then it goes to that one resistor, let's say, and then it'll go through the next one. Let's say that's like these ones. And then they collect back together here. So the current then comes down this way. Current's going up this way. Like it already went through here. And it went this way. And it's going to go in this direction through those ones. So it's sort of collecting back again and going through this last one, R6. And then going all the way around back to the end. And that's like the ground. And all the water dumps out. And the amount of water dumping out here at this point, the amount of water is the same as the amount of water that left this in the first place, right? It has to be. No water was lost. All the water coming out from here is the same as it's coming out from here. It was just a different path that the water was taking. Okay, hopefully that analogy is helpful. So that's what sort of happened here. Current leaving, current goes through this one. Current splits, goes across those two. Current comes back together, etc. Goes all the way through. And the amount of water that's able to leave from this depends on how much resistance that water is going to face. Okay. All right. So we have our RT 89.2. So we can put that in now. 60 volts over 89.2. We're getting a little messy here. I'll just start moving down to a new screen after we calculate this. So our VT is 60 divided by 89.2. So we have 60 divided by 89.2 equals 0.67. Oops. Sorry, I don't know why I was writing VT here. That was supposed to, this is for solving IT, obviously. IT is 60 volts over that. So our current is 0.67 amps. Okay, so now we have our IT, which is 0.67 amps. Voltage over resistance, 0.67 amps. Okay, so the amount of water at this point is 0.67 amps. And then it splits here, and then when it comes back together, 0.67 amps. Okay, great. So we will pause the video there, and we'll start a new one that describes what we do for the next step. So in this one, we solved for IT, which equals 0.67 amps.